Friends, welcome to the next video of the data science course using Python. Now this is very important video, so we just need to focus on the things which I am explaining in this particular video so much clearly, because this forms the base for your machine learning study in the upcoming algorithms. Many things I'll be explaining inside it, so just remember why we are using this, what are the applications of it, and when it is expected to use these particular steps. Machine learning, prerequisites and the statistics. This is what the topic names here. So many things will be covered in these particular sessions. Let's start. Type of variables. So I'll revise the definition of machine learning first. Machine learning means human experience we are giving as input to the computer algorithms, and then computer algorithm will find a pattern in that. Once the pattern is found, then we are going to do the prediction based on it. It means that the human experience or the data is containing two things, input and output. Means when input was this, what was the output expected, what was output in the previous case present there. So this is this should be known priorly before applying the data to the machine learning algorithms there. So as per that idea, there are two type of variable that every data set is containing, dependent and independent variables. Okay, and based on that, the dependent variable also having two categories, continuous and categorical variables. Let's first understand what do you mean by dependent and independent variables. When data set comes to you, that time one variable will be always dependent variable, that is what we call as output variable, and one or many can be the input variables that we call as independent variables. That understanding should be done before applying the data set to the algorithm. Let's see. So the independent variable, sometimes called as experimental or the predictor variable, is a variable that is being manipulated in an experiment in order to observe the effect of a dependent variable called as outcome or response variable. So input variable contains multiple names like experimental variable, predictor variable, and output variable is called as the outcome variable, response variables. Any name can be given to it. Imagine that, so let's take an example. Imagine that a tutor asks 100 students to complete a maths test. The tutor wants to know why some students perform better than others. Whilst the tutor does not know the answer to this, she thinks that it might be because of two reasons. Some students spend more time on revising their test. That's the first reason. Second reason is some students are naturally more intelligent than others. It means that their marks are dependent upon two things. Tutor decide to investigate the effect of revision time and intelligence score on their performance. So for our case, dependent variable, that is the output variable, is the marks, test marks, whose value lies from 0 to 100, and independent variable is the revision time measured in hours, and intelligence score, which is the IQ score of the particular student. So dependent and independent variables, two kind of variables the particular data set will be having. So recognizing this variable is the one of the most important point in our case. Remember, see, I'll take one example which I explained while learning the machine learning techniques. So let's see that example here. See, this was our example. When x and y are the inputs, z is the output. Okay, so how to find it? For example, this was the input, this was the output. It's input output were given there. I want to formulate an equation which will perfectly fit this. What do you mean by z is equal to what? So for this case, what we have, z is equal to 2x plus y. It is not fitting 100%, but you can try that. Here 2x plus y is 10, but it's 11 here. 2x plus y is also 10 here. That's perfect. Here 2x plus y is 15. Okay, we have 17 here. Here 2x plus y is 17. That is correct. But see, we are achieving the almost correct result here. Not exactly achieving 100% accuracy. So this is the model that data set is containing, input and output. So we are fitting this data, and based on that the model is formed. So z is the output variable and x and y are the input variable for our case in this particular data set. Now this is I have manipulated. This data set I have created by manipulation, but some previously defined data sets are there. In that data set also, recognizing the dependent and independent variable is the most important concern. So let's go for that. So I've downloaded some data sets with me. I'll just go to that data sets and let's check it out. Which data set are having dependent and independent variables there. Okay, so let's check this. Okay, here in home I'm having some data sets present. Just a minute. So here is the link from where you can download data sets. You can check it out for all the elements, all the data set that we'll be using, which are recognized or authorized data sets. I have uploaded on this link mitu.co.in/dataset. Okay, so here they are downloaded. So let's open one by one data sets over here, and then we'll see how these data sets, which input and output variable that they carries. Okay, so let's use one of the data sets from here. Okay, here we have one of the data sets carrying. Okay, this is empty cars. I just opened. See this. This is cars mileage prediction data set. So here these are the properties of the car shown here. Different properties of the car, and this is the mileage of the car. So mileage of the car is depending upon some of the factors that car is containing here. See this. So this is also one of the data set that cars information we can find by this particular data set here. Or let's see, just a minute, I'll focus on this particular part more clearly. One more, for example, later data. See, this is what this data set is created from OCR software, optical character recognitions. So these are the properties of the character identified from the OCR software, and which character is that, or which letter is that, which is shown over here. Okay, so A to Z values are present, and based on that we are this is what the output variable that it carries. Okay, one more, let's see this ingredients. Okay, so it contains sweetness, crunchiness, and which ingredient is that, that is shown over here, and this is the class of it, whether protein, vegetable or fruit. So this protein or vegetable is defined by the sweetness and crunchiness of it. Okay, so simple data set which contains it. Or one more I am having, let's see the banknotes data set, this one. This is identification of fake notes data set. Okay, so here we have 4 image properties: variance, skewness, kurtosis, entropy, and based on that the class of the note is identified. 0 means fake note and 1 means it is not fake note, like this. Or one more I am having here, like for example salary data. Salary, so one input variable is here present here, just like years experience, and second is salary. So years experience is the input and salary is the output for our case, dependent, independent. See, this is how the data sets are present, and every data set is containing the input and output variable, dependent and independent variables. Input and output variable that we have to recognize first. What output we are expecting from the particular data set, that should be known to us first. If it is known, then only we'll go to separate them and perform the operations on machine learning operations on that particular data. Okay, so these examples which I have shown, just try to remember it, how input and output variables are identified, dependent, independent, what output you are expecting. Maybe output variable is always 1, but input variable can be 1 or multiple, and not all are expected as input to it. Maybe we are having 1 variable, 4 variable, 10 variables, 20 variables, 30 variables, it depends. Any number of variables can be there. Now in case of output variable, okay, what output you are expecting from the program, there are again 2 types present: categorical variables and continuous variables. Categorical variables are also known as the discrete or qualitative variables. These variables are having a categories present inside it, and continuous variables are called as quantitative variables. They are having any possibilities over there. Okay, so what exactly, why we call them as categorical or continuous, what's the meaning of them? Let's see. I'll open my data set again. For this data set, this is the output variable, salary. Okay, you just look at that, there is no any categories or classes present inside it. This is continuous, any possibility will be present. So this particular data set's output variable is continuous. Okay, I'll close this, and now let's see another one. Here we have only two possibilities in 0 and 1 as output variable. That's why it is categorical. Only two possibilities are there, whether the note is fake or not fake for this data set. Let's go for another one. So this case we have class protein, vegetable and fruit. So any three possibilities are present, whether it is protein, vegetable or a fruit. So it means that it is categorical variable. Okay, so let's go for another one. See this, here letter is the output variable. Okay, here the letter is present. It means that there are 26 categories present in this data set. So this is categorical variable. Okay, so this is a categorical variable output. So let's close this also. Okay, come here. This is mileage per gallon, mileage of the car, and look at that. It is continuous variable. There are no fixed categories of mileage are present. So this is continuous variable. Okay, so just remember it all. So that's what we are differentiating. Why I am differentiating it? Because in supervised learning there are two kind of algorithms present: categorical algorithms, regression algorithms and classification algorithms. Regression algorithms are used only when output is continuous, and classification algorithms are used only when the output is categorical. Okay, that's the main difference that they carries. Now in case of categorical variables, there are three different categories are present. Basically, while using the algorithm we don't require it. Okay, let's understand that. Nominal variables have two or more categories which are not having any intrinsic order. Unordered variables are there, nominal. Inverse to that, we have ordinal variables. They are just like two or more categories, but they are order or ranked in the sequence. Okay, that's called as ordinal variables. And dichotomous variables are having only two categories or labels. You call them as binary kind of classification, like we have yes or no, on or off, 0 or 1, male or female, okay, spam or not spam. Like in this way only two possibilities are there. That is called as the dichotomous variables. Now in case of continuous variables, we are having two categories again: interval variables and ratio variables. Interval variables are for which their central characteristics is that they can be measured along the continuum and they have numerical values. Okay, for example, any temperature measured in Fahrenheit or degrees, like this. And ratio variable are the interval variables, but added condition that 0 of measurement indicate that there is none of that variable is present. Like it also contains any kind of ranges from minus infinity to plus infinity. Okay, so continuous variables are having this property: they are not sticked towards a single class or category. They are having any discrete range, any range from minus infinity to plus infinity. Okay, so for continuous variable you have to use regression algorithms, and for categorical variables we have to use the classification algorithms. Okay, so that things which we need to understand. A few more things are yet to come. So before actually going to that particular operations, let's perform one small step here. It's called a data cleaning. Data cleaning means, okay, we are having data cleaning, and after that we'll see data manipulation operations. Now first of all, when data comes to you, it may contain the missing values. In real world data, there are some instances where particular element is absent because of various reasons, such as corrupt data, failure to load the information, incomplete extractions. Okay, so handling a missing value is one of the greatest challenge faced by the analyst, because making the right decisions on how to handle it generates robust data models. Okay, now let's look at some of the different ways of using these missing values, how to process the missing values in actual programming by some programs. Okay, so for this case, the data set that we have seen last time, I'll be using it here. See what happens. So result will not generated correctly when we are having missing values in the data set. So what we will do, I'll just delete this two entries. I'll delete one more entry from here. Okay, and one entry from here. Let's use this one. Okay, I'll save this now. This data set we have seen in the last session of pandas, so I'm reusing that data set again, and I have deleted some entries from these particular columns. So once the entries are deleted, then these fields are kept empty. Now what will happen if I read this data and if I perform some mathematical or statistical operations on it, that we'll see now. So let's open your Jupyter notebook. okay, and perform the operation. So let's see. I just imported my pandas. Make sure that the file is saved in the current working directory. Okay, so read it, pandas, then okay, it'll take some time. Let's see this. Now I'm importing pandas and then reading the student.csv file and printing it on the screen. Now let's see what is actually happened over here. So that is easily understandable what actually output is shown over here. See this value is nan, this is nan, this is nan, and this also nan. Nan means not a number. Okay, not a number. Not a number is a missing value. Okay, remember it. Now these missing values will not generate the proper output. Now if you want to perform some operations of mathematics, see, I'm doing mean, finding the mean of fifth, this one, data of marks dot mean. So this is average of all the marks values present here, but not all, because one value is missing. This is the average of only 9 values, because 7th element or roll number 8 is not having the marks present over here. So this value is not considered in the mean calculation. That's why the result is not correct. Okay, for this case, if you write data of marks dot mean, same case max. Okay, so 2 ages are missing. It is finding age is 23 max, but it's working only on 8 elements, not on 10 elements. Okay, after that, okay, so this is what statistical operation can result. But now I want to find how many missing values are present in the data set, or how many non-missing values are present in the data set. So first thing, non-missing value that we can find, data.count. So count method returns the number of non-null elements from the data set. So non-null elements are roll number 10 are non-null, class 10 are non-null, class 9 are non-null, means 1 is missing, marks 2 are missing, and age 1 is missing. Okay, so count method will return the non-null elements that we can find. Now there is one more way by which we can identify the null elements. Now data.isNull.sum. So wherever the null is matching, where the missing values are present, all there I am adding together, and then I am printing it on the screen. Roll number 0 are missing, name 0 is missing, class 1 is missing, marks 2 are missing, age 1 is missing. Okay, so this number of values are missing in the data. So this method and this method, they are inverse of each other, but anyone can be chosen. How, if you want to find the missing value, the second one, and if you want to find the non-missing values, then the first one can be chosen. Now what operations we can do onto it? So let's go for this. Yes, now if I am doing some operation like this 1 colon 4 comma 4, you just can find the value first. What is 1 colon 4? Okay, it's present there. So what I want, for example, I want this 7 and 0 1 2 3 7 3. So let's try this 7 3, 7 and 3, 7th row and 3rd column. Okay, this is nan, and obviously when you want to perform any operations onto it, it will result similar nan, not a number. So in this case, what operation we are expected to do? Okay, so this is a problem of your missing values here. Now we have to find some better and proper solutions onto it, and how to do this. Okay, so there are several ways by which we can do these operations. Okay, so many operations are there. 5 different steps we can take onto it, and let's try that with the help of some practical implications. First, ignore the records with missing values. Now we can ignore the record with missing value directly and delete all the data. This strategy is useful only when less number of rows are available for deletion, or they are having less number of rows are having the missing values. Replace them with a global constant like question mark or undefined, something like this. This is the second method, but again not much useful. Third method, fill the missing values manually based on your domain knowledge. Okay, so domain knowledge, just like you know that in class only T and B are available, so just add T or B, because only 2 possibilities are there, so you can add it. Or you know that the range of the ages or age start from 19 and maximum 23, so add any random value between these two. Okay, so depending upon your domain knowledge, you can add this particular value manually. Next is replace them with a variable mean if numerical. Okay, mean of remaining values if it is numerical value, or add the most frequent value, that is called as mode, if the output is categorical in that case. Okay, so this is one of the good method that we can apply over here. Okay, and the next one is the last fifth method is use modeling technique like nearest neighbor or Bayesian rule or decision tree or EM, that is expectation maximization problems. So this also can be done, but this is complicated method. We need to understand the machine learning techniques first, and then only the fifth operation is possible. Now let's see how to do this operation. The first that we have seen is delete all the values with NAs present there. Data dot drop NA. So all the rows which carries the missing values, they are deleted by using this method, data dot drop NA. Check the output. Here we'll see the output. So all the NAs where rows are present, their NAs are deleted. See, and data is cleaned. But the problem is that how much loss we are incurred. We are incurred 40% loss here, because out of 10, 4 rows are deleted. Okay, so this is not an effective solution. If data deletion is done 10%, 15%, 20%, then it's okay. But if huge amount of the loss is there, then your machine learning will have the loss of the data and accurate results will not be generated in this case. Okay, but drop n is useful when out of 10 lakh 1000 entries are missing, 2000 entries are missing, or 5000 are missing, then also. But if out of 10 lakh 5 lakh values are missing values, then it is not beneficial or useful. So remember it, drop NA is used only when there are less number of rows are containing the missing values present there. Now what to do? So fill the global constant. So how to fill the global constant? By using fill NA. Check this, data dot fill NA. Now wherever the NAs are present, all these NAs will be filled with the help of 0. Look at it. So but let's see, the class is also become 0 and marks are becoming 0, age is 0, so it's not a Preprocessing solution. Again, age can't be 0, marks also can't be 0, and class 0, it's impossible. Okay, so that's what fill NA is doing. But fill NA we can use by some different way, so that it will accurately predict the value present in the missing field. Now how to do this one? Domain knowledge. So we don't require the domain knowledge directly, but we can apply a method called as a backfill. See this, backfill is the parameter that we are passing to the fill NA. Data dot fill NA method is equal to backfill. Now backfill will add the next value, okay, instead of it, next value. For example, so this one is missing. Okay, so 7th is missing, so here this value is added. See, sorry, just a minute, row is missing here, 7th row is missing, this 7th row, this marks is missing here in 7th row. Just a minute, method is backfill that we can perform here. Yes, this one 56.75. So next value I am putting instead of that. Here also next value I am putting instead of that. So remember, the value close to that particular value may have chances that it can be there. So exact prediction again not possible, but this is one of the good method that I can use to perform it. And instead of after backfill, there is one more method to add the previous value instead of it. Let's insert one more cell here, and it's called as pad. Pad means previous value. See this, so I'm adding pad now. So here 65.34 I got, and this 20 I got here and here. Okay, like this, here I got TE. So previous value we can add with the help of padding method, and next value I can add with the help of the backfill method. This is a useful one. In many cases it will generate some better and perfect results also. Okay, that's we can apply to fill it. Now next method, put mean or median or mode instead of it. Now see here what I have done, I am using marks. So special column I can focus on, because if I focus on all, some are categorical variable and some are the continuous variables. So class is categorical variable, marks is continuous variable. So for continuous variable I can apply the median or the mean. So let's see this. So these values were missing, so instead of that I put median of remaining values. How to do? Data of marks dot fill NA, data of marks dot median. See, so So median of remaining values I am putting instead of these NAs. So these two values are got this 66.835. I can have the mean also. Check it. See, so I have replaced the mean over there. Okay, it's already filled. Sorry, it's containing no NAs now because the data is filled. That's why it is not showing. So mean can also be used. Now if the data is categorical, in that case what to do? So there is a method called as mode that also we can use. See, what is meant by mode? Mode means the most frequent value in the categorical variable we can find. Now what value is got? Data of class dot mode, and here we have the index element. Index element, why? Because the result is in series format. Multiple elements can be frequent, that's why it is resulting in the series format. Out of it I am using 0, that's why it is 0th element I am extracting. So TE is the most frequent element that I am getting from there. Okay, so TE, and now I want to replace this TE instead of all the NAs in the class. So let's do this one. See, data of class dot fill NA, data of class dot mode of 0. So T will be replaced where the elements were missing. I think this was missing. See, it's replaced over there. So this is how you can perform operations on the missing values. Okay, it's very useful and beneficial operations to clean our data. So this operation we called as the data cleaning. So data cleaning is done by this particular mechanism. We can try on your system. Okay, so this is what the basic steps that we need to focus on. All they are explained over here. And mean, median, mode, it's one of the good strategy, and assign unique values we can apply. And the last fifth one is using the machine learning techniques like regression. But remember, we need to understand the machine learning techniques first, then we can easily predict what can be the possibility of missing value present in that location. That's is useful. So but it's complex and not generally used by the data scientists. We'll be using any one of the previous methods for working on the missing values. So as per our requirement, if values are missing, we just have to use these methods there. Now let's come with the data next point in the data sets here. So ML data sets, basically there are two type of data sets present, training and testing. Now what training and testing means? So basically training and testing are used at various stages of development. Training data set is the largest of these two. Actually validation is also there. I have given 3 there, but just we will focus on training and testing only. While test data functions are sealed of approval and you don't need to use till end of the development. Remember, the training data set in machine learning is actual data set used to train the model for performing various actions. This is actual data on ongoing development. Model learns from various APIs and algorithm to train machine learning machine to do work automatically. And testing data is data typically used to provide an unbiased evaluation of final that are completed and fit on the training data set. Actually, such data is used for testing the model whether the responding or working appropriately or not. Now let's look at this. So what we'll do, okay, so we'll go for our example or case example here. I'll just close this, and our main example will be focusing on. Now let's see. In this case, let's see what our assumptions are. The relationship between input and output is same. It means that relationship that this 3 contains is same present here also, same present here also. Correct? This is previous assumption that machine learning algorithms are requiring. Okay. Now what we are doing here, this data, so relationship are common in between input and output variable that we are assuming. So what we will do, we'll split this data into 2 parts. First 7 rows will be training data and last 3 will be testing data. It means that what we will do, so this I am changing over here like this. This is your testing data. So this model building will be done based on this data only. This is called as training data. So training, we have seen this training concept in the machine learning. Training. So to find the model or to create the model of machine learning, only this data is used, which is almost 70% for this case. Okay, model building is done, and we are going to check whether this model is working correctly or not on the remaining data, that is called as testing data. So this is your testing data, is it's called as 30% data is present there. Generally in generalized case we have 75-25 splitting there. or we can have 80-20 splitting also. As per our requirement we can do, or 1/3 2/3 splitting also, that is also possible. So we'll build a model on this data and we'll check now whether model is working correctly or not. How to check it? So for example, model is built by this, and now we are going to check whether if this value is given here, this value is given here, we are getting this value or not. So let's see this. So we are getting 21, this is correct here for second case. Okay, so if I am giving this value 2, so 2 plus 6, I am getting 8 here. Okay, correct. Then I am giving this 2 and this 9, I am getting 21, correct. 6 12 21, correct. Now what happened? So this data we call as the test. Okay, what, for example, output test, it's called as y test in our example, and this data we called as y pred. Okay, this is y test, this is y pred. Okay, so generally the names are given here. Look at that. X is the input, this is called a x train, and this is y train. Y is the output variable, this is y train. This is x test. Okay, input variable for testing, and y test is output variable for testing. Fine. So that's why I have given these particular names here. So this is your expected output original in the data set. This is predicted by the algorithm when the model is built. Model is built on this data, and we are going to predict with the help of this on these three. So expected is this, output is this, predicted is expected this, output is this, expected this, output is this. Now we are going to compare y test and y pred together. So after this comparison, okay, when we have compared these two data sets, we can identify whether the machine learning model is built correctly or not. So after the data is fitted on, the training data is fitted on the model, we are going to check whether this model is created correctly or not. Yes, so this is called as testing, and we are going to compare y test and y pred. And what's the difference in that? Based on that, accuracy can be identified. For example, our case, our accuracy is 95%. For example, here it is 100%, here we have 20% loss, here almost we have the 8% loss somewhat. So we got 95% overall accuracy you can identify. So model is working correctly or not is identified with the help of testing data. And this testing is not done sequentially. I have shown sequentially here, but actually not done sequentially. Data is randomized, then it is splitted in training and testing, and after that we are going to make the model on training and perform operation of testing on the testing data. So this is how the algorithms are actually working. But how to do this one? So let's see this, how to perform this operation. So let's again read out the things which are available for this theory. The algorithm will be trained with the training data where x is the input and y is the output. Once the algorithm is trained with the training data, x test data will be given as input to the algorithm to predict the output, and predicted output y pred will be compared with the y test to check the accuracy score of the algorithm. So in order to find how effectively algorithm behaves, we are going to do this train test split. Okay, how to do this in Python? So first example, first line which is shown here, it was the previous scikit-learn function, and second one is model selection that we will be using right now. Currently we are not used scikit-learn package yet. We have installed that in the setup video, but now this is the first time we will be using this scikit-learn function. Now how to do this one? Let's see one data set here. I'll show one data set and we'll practically do these operations here. So the data set is social networking ads. Social network ads. This is I'm using over here. Now look at that. This is data set is containing user ID, gender, age, estimated salary, and purchased or not. So purchase is the output variable for my case here. Currently, purchase is the output variable. User ID, gender, age, and estimated salary can be the input variables. Now I want to do the train test split for my case. So how to do the splitting of this data? First of all, I need to separate x and y, and then after we are going to do the splitting into train test, and after that we are going to build the model of machine learning on the training data and do the predictions on the testing data. Okay, so let's go. How to do this one? Let's read this file and then perform the operations on this data set. Yes. Okay, let's see this. First of all, I'll read the data set. Okay, then let's see the number of entries. So 400 rows that this data set is containing, and 5 columns are there. Remember that the data set and all the data sets which are downloaded, they are available on mitu.co.in/data data set. Okay, so here this is a link, we can download it. Data.shape. So 400 rows and 5 columns. And what are the columns that it carries? So these are the columns: user ID, gender, age, estimated salary, purchased. Okay, so these are the things. And now for example, I want age and estimated salary to be input. So what I have done, in input variable like X, I get age and estimated salary, and output variable like Y, I got the purchase. That is the output variable of this data set. Getting? And if you see how many rows that X is having, 400. And look at the data set now. See, so age and estimated salary I separated as X. For example, these are the input for my algorithm for building, just like X and Y we have seen. And Y is the output variable, which is having only single column is the output. This is categorical variable, only 0 and 1. These two possibilities are present inside it. Okay. Now, length of X, total number of rows are 400. If you want to see this data, age, estimated salary like this, I am using head function method. Head method used to show the first 5 entries, first 5 rows of the selected data frame. Okay. Now let's do the train test split. So here I have written the code. Let's see. From sklearn, so remember we have installed the package scikit-learn, but it is sklearn here because scikit-learn, the dash is a special symbol which is not possible to use in Python as a variable or any other name. That's why they have shortened the name as sklearn. Inside the sklearn we have a function, a model sub package, model selection. Inside this package we are having function called as train test split, train underscore test underscore split. This function is used to split your data set in two forms, in xtrain, xtest, ytrain, ytest. So train test splitting can be done with the help of this particular function. So we need to import. This is a selective import I am using from Python. And now the most important step here. See how to do this one. So I need to import that. Yes. Now let's check this. Xtrain, comma xtest, comma ytrain, comma ytest is equal to train underscore test underscore split. Okay, so its function is here. 4 output variable I am expecting from this particular function, and first input is X, which is we have seen here above. Second input is Y. Okay, output variable is Y, input variable is X, output variable is Y, and test size is 0.25. It means that out of 400, 25% will go to test. 400, 25% is 100. So 100 entries will go to test, and remaining 300 entries will go to train. Okay, and one thing I mentioned is random state. Random state is a seed point. Okay, so data will be by default randomized, but every time we will have different randomization. If we keep the seed point same, every time randomization of the data in train test will be same. Okay, and now data is splitted in this format. So let's see this one. This format, 75% are going to train, 25% are going to test. They are splitted xtrain, ytrain, xtest and ytest in this particular way. And now if you see the length of xtrain and xtest, see this, 300 are in training randomly, not all in sequence, and xtest in they are containing 100. They are remaining 100 entries are going to test. Now after this we can just check it, the data is randomized or not. See this, both xtrain dot head. So this is what we got, the training data. First entry 250, second 63, 312, 159, like all. Out of all 400 rows, 300 present in train and 100 will go to test. Now see the train and test, they are not changing here in X and Y. First entry 250, 63, like all, and this is output variable which also contain the same data carried along with it. Means when X and X was input was this, output was 0 for our case. Okay, and go on using it like. Okay, so this is how train test split is done by the train test split function, which is used here for performing splitting operation on the training data into onto the basic data set to transform them into train and test format. Okay, so this is how we are doing the operations of splitting the data in train and test format. Now let's see. So this is, so operations are done there, so remember it. Okay, now after that let's see few pre-processing operations required by our algorithm. Now pre-processing, what's required? Let's see. First pre-processing technique is called as feature scaling. feature scaling, data processing applied to input variables, or we call as features of the data. Feature means the input variable itself. They are also called as features. Basically helps to normalize the data within a particular range. Sometimes it also helps in speeding the calculation in the algorithm. Now why to do this one? In real world data sets contain the features in varying magnitude, units and range. Remember. Okay. So normalization should be performed when the scale of feature is irrelevant, misleading and not normalized when the scale is meaningful. The algorithm which uses the Euclidean distance formulas, or they are sensitive to the magnitude basically. So feature scaling is required to perform the operation. Let's see why feature scaling is expected. We'll go to our data set now. So the data set is here, this one. Now let's consider an example. So this range of x and y are same. X and y are same. They are within the range of 1 to 9 something like this. Now just consider it. Here the range is something higher. Okay, the ranges are higher. It's very high range of a variable is there. Now let's remember one thing here. In this formula, y will have highest impact in the output. Now let's look at that. If I am adding this 42,532, 52, I am adding 3 only inside it. 3 into 2, 6. So only maximum x have 6 difference, but y will have thousands of impact into it, and x will have only 6, maximum 6, not more than that. So this value output will change because of x by plus 6 or minus 6, but because of y in 42,000s. Remember it. It means that y is having highest impact in the output. It means that if you don't consider x, then also output will not change much. So x is not having the impact in the output. So that may happen for many different kind of algorithms. Okay, so what machine learning says, all input variables should have similar impact in the output. Many algorithms like support vector machine, k nearest neighbor, logistic regression, these algorithms are having this particular thing, okay, inside it. Okay, when we are having highest impact in the output because of magnitude, when output changes because of magnitude, not because of relation, that case we require to scale our data. Okay, so if feature data set is big scale compared to others, where algorithms where Euclidean distance measures are used, so becomes dominating and needs to be normalized. When values are higher, when you have to normalize the data. So there are two ways by which you normalize the data. The first way is called as feature scaling. Okay, so feature scaling. Feature scaling is done with the help of a class called as standard scaler. What's the task of feature scaler? Feature scaler, standard scaler that we call. Feature scaling makes the deviation of all the columns in the data set at the same direction, or they will make almost standard deviation equal to 1. You might be knowing standard deviation. Standard deviation means, standard deviation is the distance of the respective point from the center or from the mean of all other elements. That's called as standard deviation. If you are keeping standard deviation 1, the variation in the data set will be removed almost, and every element is having deviation almost equal to 1. So if you are making deviation equal to 1, all the values will behave similarly in the output. So to do this one, we are going to perform the feature scaling, or we call them as standard scaler also. So let's see how to do this one. First of all, let's check this standard deviation of the data. So for this standard deviation, we are having 10 for age, and estimated salary we have deviation is 34,096. Okay, this deviation is present here. Now I want to make deviation of both of these columns same. So to make the deviation same, I want to import from sklearn.preprocessing, import the standard scaler class. Standard scaler is a class to perform the feature scaling operation, which makes the deviation of all the input columns to 1, almost equal to 1, not exactly 1 but almost equal to 1. So let's import that class. Now create the object of it. This is how the object are created. We are knowing how to do that one. And now I want to apply the feature scaler, standard scaler, to the data set x. It's applied. I got the scale data like x underscore scaled. Okay, so this data is scaled, and now let's print it. So basically x scaled is in numpy array format. I need to use standard deviation function which belongs to data frame format. That's why I have typecasted that to data frame dot std I have done, and then I have printed it here. Let's look at that. Now this is done. Check it. Okay, 1.001252, here also 1.001252. is created. It means that we have transformed this data into feature scaled format. Okay, so deviations of this data is now same of both the columns. It means that now they are having similar kind of impact in the output. Now just look at this particular concept here. 10 and 34,000, it means that estimated salary may be having highest impact in the output, but age is having very less impact in the output. So that we have done that, and now their deviations are same. It means that now they will be having similar impact in the output. So when some algorithm requires, some algorithms are having dominating features, that case scaling is required. If some algorithms are not required, not having dominating feature, then it's not required, but if you do it, then also it will work perfectly. Correct? So remember that deviations are created in same range with the help of this particular function. Now second method is called as normalization, that we call as min max normalization. Normalization means now we can rescale our data in a specific range. Basically all the data is decreased, is normalized within the same range. Okay, so for example, I am having a sequence called as 1 2 3 4 5 6, and I am having sequence called as 10 20 30 40 50 60. Now if you see, their relation is same. See, if I write it here, just look at that. For example, I am having 1 2 3 4 5 6, and one more input called as 10 20 30 40 50, okay, and 60. Now see, this is low magnitude, this is high magnitude, correct? But the thing is the relation among this is exactly same, that their relation is there. So relation is not changing. But if this magnitude changes the output, not because of relation but because of magnitude, output is getting changed, in that case we have to normalize the data. So normalization will be something like this. We are going to scale this data in the same range. It means that here in this case we'll just decrease it like 0.1, here 0.2, 0.3, in this way, like go on, and same data will be scaled here also. If you scale this data in the same range, the relation will be same inside it. Now how to do this one? So to do this one, we are going to make use of the min max scalar function here. So let's see, describe. So if you describe that, you can see the minimum value is 18 here in age, maximum is 60, and estimated salary minimum value 15,000, maximum value is almost 1,50,000. Okay, so their values are different, their ranges are different. That's why we require to apply the second function called as min max normalization. Now how to apply min max normalization? Check it out. From sklearn.preprocessing, import min max scalar. It's imported. Min max scalar is a class to perform. Create the object of it. Scalar is equal to min max scalar. Then xscaled is equal to scalar.fit underscore transform. Same function. Fit transform means get the data pattern and apply it. Fit is used to get the data pattern, and transform is used to apply that data pattern on the given data. So the pattern is applied on that particular data and the data is transformed. Now let's see, let's describe it. So if I describe it, see this, now data frame dot xscale and dot describe. Now let's look at that. Minimum value is this. So basically what this algorithm does, this algorithm keeps lowest value 0 and highest value 1, and remaining other value will be scaled within that range. It is useful to scale input attributes for a model that relies on magnitude of values again, such as distance measure used in k nearest neighbor and in the preparation of coefficients in the regression. Okay, so there this algorithm can be applied. Normalize your data within a specific range and then apply your algorithm on this particular data set. So if some algorithm is having changes in the output because of magnitude, that time normalization technique can be applied. So first or second, remember, feature scaling or normalization can be applied. Both are not beneficial at a time, but any one of these can be used to perform these operations. So min max scalar will perform normalization of the data within the same range. Now the next one is called as binarizer. So let's see what I mean by binarizer. Binarization. Binarize data. Set features value 0 or 1 according to threshold. Now let's look at it. For example, if someone is asking you the temperature, so I am telling temperature like 35 degree, 36 degree, 40 degree, 20 degree. So these are analog values. But if someone is asking whether temperature is high or low, so what we will do, we will keep a threshold like 30. Above 30 temperature is high, below 30 temperature is low. So if some algorithm require the data in this binary format, whether yes or no, whether low or high, whether on or off, in that case binarization technique is one of the useful technique that I can apply over here. Now how to apply that binarization? So values are greater than threshold will map to 1, while the values less than or equal to threshold will map to 0. Okay, so that's how we can do it. So some algorithm may require this, and how to do this one, that I will show. So first of all, import the binarizer from sklearn.preprocessing import binarizer. Then create the object by keeping a threshold value there. Okay, so binarizer equal to bin equal to binarizer threshold 30, and then fit transform, and then check it. See, scaled bin dot fit transform x, and now wherever in x values are greater than 30 will be 1 and less than 30 will be 0. Look at this. So this scale I am applying to data frame when it is 0 and 1 column is there. So all of these values are above 30 and all of these values are below 30. Okay, if you want to use the first 10 entries, check this. See, so these values are above 30 and these values are below 30. Okay, this is what we call as the binarization. So binarization technique is one of the most useful technique here to convert your data from analog value to the digital value. So but we need to keep the threshold value above which you represent 1 and below which represent the 0. Okay, so that's how we can perform the operation of binarization. And now let's come with the last point of this presentation here. It's called as encoding. Many practical data science activities, the data set will contain categorical variables. These variables are typically stored as a text values, like if you are having red, blue, yellow, or we are having smile size like small, medium, large, or geographical destination like state or country. Regardless of what values used, the challenge is to determine how to use the data in the analysis, because every machine learning model is having a statistical model, mathematical model there. Mathematical model will work only on numerical values. If the values are categorical, if the values are string, then what to do? So we need to transform that data into number format. So this number format conversion is done with the help of the algorithm called as encoding. So methods for encoding are called as label encoding and one-hot encoding. There are these two types of encoders are the part of scikit-learn library in Python. They are used to convert categorical data or text data into numbers, which our predictive model can better understand. So let's see how to do the label encoding for our case. So what I'll do, I'll make use of my original data set, which is student.csv. Okay, so without having any missing values there, and let's convert these columns into encoded format. So let's go for this. I'll write these values here. Okay, it's PE and this is okay. So let's save this and let's read this. So let's read this file again and see the data. Yes, now label encoder. What we'll do, for example, class. Look at the class. T and B are present there. So this is categorical variable. I want to change these values. Okay, so first method is label encoder, that can be used even for name also. Label encoder can be used to convert your data. Now see how to do this one. Here, see sklearn.preprocessing, import the label encoder class, create the object of it, then fit transform. So create the object here, and then data of name dot le dot fit underscore transform data of name. It will apply on individual columns only. Apply and replace it. And now let's see what is actually happened over here. Names are replaced by the numbers. 0 was the first name, maybe Ajinkya is present there, then go on using it. This is Ayesha, last entry present there. Numbers are given. But remember that one important thing here, converting number in this format, it is not having any interpretation. Algorithm can't interpret anything out of it. Okay, but if categories are like binary, like T, B, 0 and 1, then it is having impact. Okay, whether it is T or B. But if multiple categories are there, then we are giving some numbers to these categories, then interpretation will be wrong in many cases. Okay, so that label encoding will not be have much benefits out of it. So what we will do, we'll apply the second method called as one-hot encoding. See, label encoding, how to apply. Label encoding has advantage that it is straightforward, but it has disadvantage that numeric values can be misinterpreted by the algorithm. What's the meaning of 0? What's the meaning of 8? What's the meaning of 5? Okay, numerically these values are less or more, but Is there any difference between Ajinkya and Anmol? No, actually, Asha or Ayesha, no differences are there. So misinterpretation of weightage can be done. That's why label encoding is not much preferred. So what's an alternative approach? It's called as one hot encoding. The basic strategy is to convert each category into a new column and assign 0 or 1 to it. Okay, so benefit of not weighting a value improperly, but does not the downside of adding, does have the downside of adding more columns to the data set. Yes, more columns will be added. Let's see how to do this one. So read data set again. Now in pandas PD there is a function called as get dummies. This function I am converting a whole data set into the one hot encoded format, and now see data encoded is equal to get dummies, pd dot get dummies data encoded dot head. Now let's see what happened. Roll number are same, marks is same, age is same, but name Ajinkya, this is name Ajinkya, name Amar will be present below, name Amit, name Amita, name Amol. Now let's go on using it. Now see class T, class B, every categorical variable is created as a separate class, and where it is present there it represents 1, and where it is not present there it represents 0. This is what we call as one hot encoding. Every category is given with a special column, and that column is present in that row or not can be identified with the help of this particular system. So by this particular method we are going to convert the data into one hot encoded format. Okay, and a disadvantage that we have seen is the shape. See the shape, 10 rows and 15 columns, only 5 columns were present, 5 columns are extended to 15 columns. It means that the name is extended by 9 and the class is extended by 1. Okay, and that columns are created, you can check it out. It's called as one hot encoded. Now see the complete data is there in numerical format. Okay, one hot encoded, and but advantage is that perfect modeling, we are not getting any data loss. Data is expanded. In label encoding, make sure that the data is we are having a data loss there, but in this case we don't have any kind of the data loss. That's what advantage is there. So as per algorithm requires, we just can perform the operations whether to perform label encoding or the one hot encoding. So these are the common different techniques applied for data pre-processing tasks. Maybe some algorithm will require that, why, when and where they are expected, that we will see in the upcoming machine learning algorithms. Till then we just practice all, and we'll start with the machine learning algorithms from the next session. Thank you. Thanks a lot.